Yeah. No, yeah, I'll give it a little bit. All right, guys, I think we're gonna get started here. Thanks for jumping in. Yeah, so welcome to my workshop. Um, I'm Oscar. I'm with the engineering team at Fedi. And fortunately, my demo didn't work out. I was just grinding this morning, trying to get it to work. But I got really close. Maybe, depending on how we want to use the time, we could just hack on it together towards the end. But the goal of this is just, go through some basics actually, just like ecash technical basics. I feel like a lot of times you go to these technical conferences and everyone but just kind of expects that everyone understands the basics. So it might seem rudimentary, but I like going through the motions just in case, there's some people that just kind of take it for granted and they don't actually have it clear how it works. So we'll do a little bit of basics. We'll do a little bit of like kind of anatomy of an ecash note. On my end, I'm more familiar with the Fediman ecash than the cashew, but I did read up a little this morning, and so maybe we could just go through both. And then, yeah, so transmission methods, what I mean by that is, ecash is the data. So there's just any way you can transmit data, you can transmit ecash. So what I'd like to see, kind of in the ecosystem are creative ways to just transmit data, and I'll go through a few of the methods that, at least in the Fedi app, we have. And then, yeah, so basically one of these crazy ideas, let me move on a little here. So yeah, that's me. Nice to meet you all. So yeah, like I mentioned, we'll do some basics. And so basically these three ideas. The third one's just kind of for fun, but you get the idea. Copy pasting, that's familiar, but it's also, there's a lot of friction to it. Animated QR codes is kind of a new way. I mean, a newer way. It's a little more familiar. People can scan QR codes, but since you're actually dealing with quite a bit of data to fit into one QR code, if you animate it, then there's a nice kind of visual method for transmission. And then this last one is the fun one, is audio. It's like maybe we can transmit ecash over audio. Like theoretically, it's perfectly possible, and that's what I was trying to get to work on in my demo. And I couldn't quite get it there, but I mean, we'll go through the idea and just, you know, it's a fun idea anyway. Maybe I'll present it for the hackathon if I can figure it out. But yeah, just remember, like, the text form is at the end of the day what we're talking about. Like the QR codes boil down into text, the audio boils down into binary ones and zeros. So yeah, ecash basics. I'm sure we've been learning through whatever talks. The money is the data. It's a bearer token. Anyone with a copy of the unspent ecash token can request a fresh token from the mint, invalidating the previous one. So I just kind of put together a little diagram visual here. Alice has a 10 sat ecash note. When she wants to send it to Bob, she copies it. So she transmits it by, you know, whatever means, copy pasting, animated QR. And then now they're, you know, put these in yellow because now it's kind of like in a race condition mode, where whoever decides to go up to the mint to refresh first gets the fresh ecash notes. So after the reissuance, both of these copies are now invalid because the mint stores all spent tokens to obviously prevent future spend attempts. You can see this the little dot up there that the mint keeps track of all the spent tokens. So yeah, basics. This is what an ecash token looks like. Yeah, you can obviously copy paste that. Copy pasting has a few properties. It's simple. It's just like, okay, it's text, you know, dumb enough. Cumbersome and ugly. Like, imagine copy pasting this. There's this little video copy. Imagine sending your friend some money by doing this. Chat. Okay, go whatever, WhatsApp, Signal, whatever it is, and you're, you know, we're 15 seconds in already. Like, paste, boring, ugly. This is not. We want to do better than this. So yeah, that's what an ecash note looks like. And yeah, so at least the Fedimint type of ecash, you know, looks like that. The cashew ones have a little prefix and a version at the beginning. But yeah, at the end of the day, we're looking at an encoded form of binary data. It's base 64 encoded, at least, you know, the Fedimint version. The cashew version is CBOR encoded, which I thought was interesting. I don't know, that at least the CBOR website, you know, made a pitch for how we have JSON encoded data, and you know, typically gets encoded into base 64. But at the end of the day, they look pretty similar. The Fedimint one has the Federation ID prefix, which the cashew counterpart would be within the JSON. You have a field for the mint URL, and then the notes of each denomination. So what I want to show here is just kind of, you know, what is the ecash note exactly? It has a signature in there, but it also has an amount in there, not in the way you might think. Like, you know, a typical Bitcoin transaction, you know, might have amounts, but you got to add things up basically. And basically what I wanted to show you guys here is, at least with the Fedimint CLI, it's a little small. So yeah, there's a little command here. Actually, let me just, yeah, 1 second. Let me also make this bigger. How do I do that? Yeah, okay, let me just pop this open. Get this out. Okay, so yeah, I mean, I have the Fedimint CLI built in. I just built it using Nix. And so Fedimint CLI, you can see all the different commands. There we go. The Fedimint CLI, if you want to play with that, I highly recommend it. It's pretty fun. So here in the dev command set, we have a little decode function. So we look at that help doc. You can decode invite codes, notes, transactions. So we're going to look at notes right now. And you basically just pop in the entire note. And so this is going to show us what it looks like in JSON. Right, so as I was saying, we have the Federation ID prefix and then this notes field. And so if you look at these, the keys, right, it's the denomination is basically the amount of MSATs that you have an ecash note for. So if we add all these up, 32, 64, and you have to use, I believe, the number of elements in this array, right? So I have 132 MSAT note with a signature and a spend key. And so if we, let's just go ahead and do this, plus 64, plus 256, plus 512, plus 8192. Like exactly. 32768. Each of these have one each. 0172, 262144, 104, 8576. 1.5 million MSATs, so 1,500 sats. That's what this ecash node contains. And so just to validate, let's go ahead and pop this in. I forget which federation. I think it was one of these public ones, Bitcoin Principles. So yeah, the other thing I'm going to show you guys is our source available repo. You're able to build the React Native app from that. So I highly recommend you check it out. But here, let me just join the community first. And I'll also do this the other way around. We'll generate one from the app and then decode it. Ignore that little start listing. That was my failed demo. Did I, yeah, I must have messed something up on my, actually get some money from the faucet here. Let's just do it the other way. Said I'm not sure why. I probably busted code while I was doing my demo. But if we look here, okay, got some money from the faucet. Let's generate one. Let's see. Let's try to get an easy multiple here of MSATs. Let's say, this is gonna be tricky. So one sat. What's the easiest way to divide by 1,000? So this is another interesting part. The client side logic is, you know, for any given sat amount, we're trying to like efficiently subdivide into all these different denominations of ecash nodes, and there's a whole, you know, logic to it. Basically, like you might already have a bunch of one denomination of notes, and you kind of, I think the principle, someone correct me if I'm wrong, is like you kind of want a blend of everything. You don't want just two sat notes or two MSAT notes. And obviously the different amounts that you make, even like you can even consider like how often or like the types, the amounts of payments that you make on a regular, like if you're doing lots of large amounts, then you might want a different type of denomination blend. So yeah, there's some nuances there that's kind of worth maybe researching a little bit, exploring more about note selection. But yeah, anyways, let's see here. So what would I do here if I wanted an even number? 32, 512. So 512, 488. I think we kind of got to go down in multiples here. 256, 128, 64, 32. Okay, so let's do 1,000. Let's try and just do, what's 1,000 minus 512? Is that what I want? 488. No, that's not what I want. I'm confusing myself. So let's just do, let's see what the algorithm does just with 1,000, right? So I kind of expect it to give me one of each of these denominations if I give it one sat. Because remember, we're talking about MSATs. And the fees are probably going to throw off everything, actually. Do we have any fees? I don't think so, hopefully. Let's check this out. So, salt bin, Fedimint CLI. Dev, decode, notes. Nope. Oh, you're kidding me with the Android clipboard. There we go. All right. So, as you can see, We got one note of the ones we were expecting: 512, 256, 128, 64, oops, and 8. So you get the idea. You gotta, select the denominations that you want. So anyways, moving on a little bit. Yeah, so copy pasting, the other thing I want to mention, this is obviously the blob, the text blob that you can put into things like some of the functions in our web SDK. Validate notes. If you pipe that into validate notes, you're going to get the amount of MSATs we're just looking at basically. It's going to decode, it's going to count everything up, and you get the amount that notes represent. You also pass those right into the reissue external notes function, which is basically an operation, right? So Fedimint has got a lot of state machine logic. So basically, the first thing you get from this function is an operation ID, which corresponds to an operation that can only have a certain number of states. It can only be in one state at a time. So obviously, it starts out in like a created state, and then as those notes actually get reissued, because you might be offline, for example, you might not be able to make a request to the Federation just yet. So that operation is going to be in a particular state, depending over time on what that operation is going to do. So at the end of it, once it's finalized, you'll end up with the notes that you're looking for. And so you kind of just subscribe using that operation ID to the updates of the operation. And then once you see the finalized state, that's going to give you maybe your new set of notes. Actually, we'd have to check in on that particular function. Or rather, not this function, but the subscribe function. That, and you can look up at the documentation, and that'll give you everything, all the information you need to know. So yeah, that's all on that. Any questions so far? Following along, pretty basic. Cool. So yeah, we've got this new idea here with the animated QR codes. And we can poke around the code base a little bit on how we're doing this. I actually don't think there's too much, we haven't given a lot of thought into like optimizing for this. We kind of just like took the whole note, split it up into even number of frames, just like split the buffer up, and then we play this on loop over and over. And so as you're scanning it, depending on the quality of your camera, maybe you'll skip a frame, but it's okay because you'll come back around and get them all eventually. But user experience wise, we really want to not have people just kind of standing there. We have a little progress bar too, so like it'll tell you, okay, 1%, 2%, 10%, and it depends on the number of notes too. Like if I have a perfectly divisible multiple of the denominations, it's going to be pretty short because it might be just 1 or 2 notes. But yeah, just depending on that, you're going to get a longer loop of frames here. So yeah, there might be creative ways to optimize for that. You might be able to think of it as, you have device, receiver, and sender. So the sender is displaying QR to some kind of out-of-band communication, or maybe even directly in the visual somehow. But so you basically want the receiver to try and tell the sender that I already have these frames, and so can start to just remove the frames that you already got, so we get fewer loops. And that might cut down on the actual time it takes to complete the transfer. So yeah, again, very basic. This is one of the things we have in the Fedi app, this animated QR code. And so yeah, that's familiar to people. I mean, the only thing I've seen is people are like, oh wait, why is that QR code moving? But they don't have any trouble realizing that they have to scan it. So yeah, it's a little more efficient. And yeah, user-friendly. So.
Is it using the same one as maybe, I don't know, Cashew and other, like using the same library?
Yeah, let's check it out a bit. Let's take a little detour on the presentation, or rather the slideshow. But yeah, so here, this is that open source repo I was talking about, all my non-functional demo code. But yeah, so let's see, where's that file? Animated QR code scanner, not the legacy one. Let's find where this is. Get that here. Okay, QR code scanner. Let's check this component out. And no, it's not the scanner. Yeah, well, the scanner scans the frames, if I remember. Okay, yeah, here we have some logic. So we have this thing called a frames reducer. we get the progress of the frames, and we know, whether or not we're complete. But for QR is different. So, yeah, I got the parser. Okay, QR loop. That's the little library we use.
Reason I asked is because it's the same. Like many things are trying to solve the same problem. Like this is
Mm-hmm.
a universal problem to solve for it. Another one is like it was mentioned like the screen quality. So like if my camera or the lighting can't read, then it could like deteriorate into like a worse quality one with bigger squares, but it's going to
Mm-hmm.
take longer time, but it's going to go through.
Right. Yeah.
Like
Yeah, that's another good idea. Yeah, so basically just how can we improve the communication between who's scanning and who's displaying the QR? Like, why not like establish a little channel between them and try to say, hey, I'm low light, like, can you change?
we do it in person, like when we
Yeah,
we're like try to move in a little closer,
right,
or like
exactly,
turn up your screen display brightness, etc.
exactly. And yeah, so that's something I would encourage people to look into. This is one of the friction points, and again, even with just lightning invoices, like you get these awkward situations where you're like, oh, I can't quite get there. So yeah.
You ever play with the seek timers?
Personally, no, I haven't. I've heard of it.
Pretty excellent experience. They have a little slider to dim and brighten
Oh,
the
nice.
scene as well.
Yeah, great. Yeah, stuff like that. It's only going to be more important with this animated QR because it's more data. Yeah.
So the cool thing about Piano is actually that the frames will never repeat. So like the more frames you scan, like at some point if you have enough of them, your probability of decoding the message goes up exponentially. Like it's a fault code that they use, and so you actually don't have to wait to come around to the same QR code that you missed. So that's pretty cool about it.
Yeah. I mean, I don't think we actually implement that feature of it.
The art is doing that, like with library.
Yeah, I don't think.
Search for fault code. I think it's written over the weekend.
So I know we're using this to display, but I'm not. Actually, you might be right. Actually, we'll check.
Yarn is generating the pieces of data, and then we're sending that to the jar generator.
Yes, there's no communication right now between the two. But yeah, I think you're right in the sense that, we should be. I guess we are using it on both sides. One, when we're parsing, and data to frames while we're displaying. So I'm sure these guys have thought about something like this. But yeah, I'm not sure. Yeah, I mean, they don't repeat. Maybe I'm misunderstanding this library. But I mean, you have a certain number of phrases, and it's going to go through. I don't see how out of the box you would just be able to kind of know what the other person's already scanned. Oh, I see what you mean. Okay, I got you. Cool. Yeah, anything else on this topic of animated QRs, ideas?
It was terrible. It's a shit idea.
Like nice looking or?
No, like dealing with, like it's such a pain every time. Like dealing with building it and yeah, just it's anybody who builds a scanner of animated QR codes, you know how painful it is. I don't know how to fix it.
Yeah, I mean, you see.
So also like QR codes, if you tell people today, they're like that's kind of like the payment system of the 2010s, not of the 2020s. So like, can we see Bluetooth, audio, NFC?
Right. Yep. Those are the other ideas that I'd like to explore more of. But yeah, anyways, animated QRs, cool stuff. So here's the fun part, I guess. Audio streams, something called frequency shift key encoding, frequency shift keying encoding scheme, roughly. And so we're dealing with binary data. This is basically how it works. You have ones and zeros, and you choose two different frequencies, one for the ones, one for the zeros, and then you put it on a carrier wave, and you end up with this clearly distinguishable, easily recognizable on the receiver side of a certain frequency for 1 and 0. And so you just modulate quickly between them, and you should be able to pick up the data on the other side. So yeah, this is the thing I kind of wanted to demo, but we can get into it. We can also explore. I guess I'm happy to just jump right into that and try to make it work, or at least I'll show you like the boring copy paste version. But I kind of wanted to just like get it right in the app, like it's listening in and it just updates your balance. So if we want, we could use the rest of the time, the workshop time for that. And we'll poke around the Fedi code base. We'll learn a little bit about kind of how things work there. And yeah, let me just see. Yeah, so if there's no other input on that, I think we'll just cover that. And I'll kind of walk you guys through what I was trying to do this morning. But let's see. Okay, so there's this library called quiet.js. That's over here. Right, so quiet.js is basically the library I found. And I was trying to get it working in React Native. Maybe I could just try it on web. That might be more promising because I was running into Android build issues. But I'll show you their example. And let's see, maybe I can just do this from my phone actually. Where did I put that? Okay. Let's see how loud this is. So it sounds like that. Not great, but there's also an ultrasonic version. I'll play that next.
You gotta make it sound like the modems of the 90s or something.
Yeah.
Can you use this to scare off teenagers?
Potentially. It's like, take my money, run away. Yeah. Cool, yeah, so this little example app they've got. What's that? Let's see, so the Audible one here, so they have different profiles. We can try and make sense of it together.
You're gonna have the same thing as with QR codes, where it'll be like, well, you need to speak up, or you need to go slow down, you need to, depending on the quality of the audio, you'll have the same sort of like the quality of it.
Yeah. Yeah, so this library actually uses something called GMSK, which is like, it's basically frequency modulation, but then you do like a Gaussian adjustment to it. So like, you just, kind of smooth it out a little bit so it's easier to pick up if there's like interference. So yeah, these are the specs. If you look at the library, it's just, that's the Audible profile. There's a checksum scheme, modulation, the frequency in the middle of the two that it tries to target. And then, yeah, some other parameters down here. And they've got a ton of other profiles, but that's the one that's on this website. And then the ultrasound sounds like this. Can't really hear it, but that's the point. But let's maybe try that one, the ultrasonic one. All right, so start ultrasonic receiver. Where's my mic? Where's the mic on the MacBook? That's not working. Let's try the Audible one. I think is a little more reliable.
Scares off teenagers.
Hold on, let me probably refresh the page actually. All right, come on, let's get an actual. I think it says 50%. Let's see. Huh.
Is the sound being firm routed somewhere?
Can you open your audio settings and check what the volume is?
Yeah, I bet just this whole setup might be messing with it because that was working pretty clean before. Let's try one more time here. %50% or lower, okay. Okay, we got a little bit. All right, we got something. Let me replay it. A little bit of packet loss there. Yeah, it's pretty rough actually. I probably shouldn't be talking while it's trying to read it. I wonder where the mic is on the MacBook. So yeah, I mean, we can see, right? So packet loss, that's like kind of the frames of the QR code in a sense. We could only get 5 out of the 16. There might be more. So we didn't even get the full ecash note in here. I think we got the end of it. Let's see. And it's in segments, what's interesting. So this is all good. And it doesn't do it in pieces either. Or no, it does. I think it's concatenating. I'm just comparing from what I see on my phone. So RZ, so this, it caught. This last bit is what I see on my transmission side, but then there's a missing piece, and then it picks back up. Yeah, so it's concatenating each of these frames together. You get the idea. It's just pieces getting transmitted through. And yeah, so maybe, I mean, let's see, if I'm trying to do this now and it's not working on the web, it's probably not going to work if I try to do it on the React native app. But we can poke around the code base anyways, just for fun. Okay, so let's see. QR code scanner. Let's get back. So I was just hacking around in here. QR code scanner. Was that it? No, what was it? QR screen. No. What is that? Scan. Omni scanner. That's the thing. So yeah, actually, this might be something cool to walk through. So we have a thing called the Omni scanner, and it's this clean little piece of clean little component that just like we scan so many things in the app, lightning invoices, addresses, people's chat member QR codes, ecash. So we built a component that kind of is just like super flexible. We can put it on any screen we want and kind of just tell it what types of actions it can expect, what types of data. So this was the component I was starting to have with. Gave custom action just to add on. That's what you see down here. This extra little item. So we have paste, and then listening would have been this. Okay, the stream through. But then the Omni input, and I'll just kind of show you the little parsing layers because it's in the Omni input component. We, based on the expected input types, we derive this just kind of Boolean as whether it can scan a certain data type. So LN URLs, searching for chat users, and then the actions based off of whether you can search or not, we'll add it on. So we kind of have like this idea of a context depending on if you're looking at the top level QR scanner or if you're clicking the send button. And so each time you see a scanner, we kind of like inform it with a certain amount of context so that it tries to kind of pick up on what the user's trying to scan. And even if like you're on the send Bitcoin scanner and then you scan a Federation invite, it's like people might do that. Then we do kind of have a little pop-up we have here. Where'd that be? Omni input, I believe. Oh yeah, that's in here. So where's that? Parse input, handle paste. What was this called? Props. Oh, Omni confirmation actually. That's over here. So yeah, so here. Oh, that's kind of hard to see. So depending on the type that you end up, basically after we detect, it's like, okay, this is the data that they're trying to parse with. This is kind of the what that little confirmation window will be. So we picked up on LN URL pay. Hey, you're trying to pay a Lightning, an LN URL pay. This is the screen we send them to. We pipe the data through there. LN URL withdraw similarly. If it's a Fedimin invite, we go over to the Join Federation page. If it's a community invite, same, well, communities and federations are actually very similar. ecash, that's going to get you to this page where it is specifically for ecash. LN URL auth, you get the idea. So, so yeah, nice, just like a standardized interface for just anything and everything that we could possibly want to scan. We have kind of standardized code to say, this is what you should show in that content screen and what you're going to do when the user wants to continue. And then the little icon that you want to show if it's supported, right? Okay, anyways, where was I? So we're coming back to the Omni scanner, and I'll just show you guys the parsing logic there as well. Where's that parser? So yeah, these are all the different types of data that we support in our Omni scanner. And some of them are actually supported right now, but we were preparing to support, for example, Bolt 12. We don't support yet, but we thought of it. We wanted, this was like, you know, a year and a half ago before it finally started rolling out. But yeah, so just some nice TypeScript interfaces for if we have an LN URL pay, what's the data that we expect to see in that type. BIP21, this is some of the old chat, the legacy chats code we're using, and the actual parsing logic is in our utils. Here we define sort of certain things that you can parse before you join a federation. If you're doing a recovery, there's certain things you can't do yet. And actually, this is the top level function. So we have to imagine that they're going to put in anything in there, whether it's pasting or scanning. And so we're running all parsers simultaneously, and whichever one resolves successfully first is what gets identified. So that's there. And then yeah, each individual parser's logic. Let's look at the ecash one just for fun. Parse Fedi mint ecash. So yeah, like I mentioned before, validate ecash or validate notes is where we pipe that through, and this will end up returning, let's see what's in that data type, just the token. So yeah, we basically have a function, that's actually different than the one I showed you. Was it validate? Yeah, well, obviously, yeah, so you can give it any string, and if it's just not anything even remotely related to ecash, it's gonna error. But if it is, this interface actually might be different than the one in the web SDK, because this says it, wait, that's not the return type. This is, let's take a look at the return type on validate ecash. RPC ecash info. That type here does have the amount and the federation ID. So yeah, that's congruent with the other one. So okay, so then let's see. Try to get this audio listener going. So I got it. So make a sound. Oh yeah, I was running into this issue with. Let me find the right screen here. Bear with me. Screens. Was it here? Yeah. Okay. So yeah, quiet.js. Since it's not a React Native library, I found some guy who made a wrapper 4 years ago, but it didn't compile, and so I got it to compile, but it doesn't have all the features. Like I can get it and make sound, but now I'm seeing that you guys can barely even hear that actually. Yeah, that's the, I can hear it, you guys can't hear that, but let's see, so if let's do this. So that approach, I don't know if it's gonna work without really messing with Android, but this other library, we can see the byte stream. Where did I put that? Start listening, live audio stream. Here it is, okay, let's try that one instead. Okay, here's the, so yeah, I'll walk you guys through this approach, which didn't quite work out, but, or rather, it would have taken me a lot longer to figure out. But okay, so here we've got the logs, and wait, set up. The code once they're granted. We set up a listener for this live audio stream library, which does seem to actually pick up my audio from. So you get a decode it from base 64, and then I'll just kind of show you guys what it looks like. If I try, let me stop it as soon as I see the first one, just so our log does. All right. So go over here, start listening. Okay, let me log more of that actually, sorry. Let's log the undecoded. It's raw. And yeah, this kind of match it. Buffer, what is it now? Somewhere, speaker. Forget where they put it. Speaker transmissions of profile transmits around the 19 kilohertz range. So yeah, I couldn't figure out how to specify frequencies. I'm pretty sure I had to I basically had to build a DSP module getting this raw. Let me just show you what it looks like. So data decoded. Let's hide this for now. There it is. Okay. Let's get this out of my. Oh, that's actually quite a lot. Oh, there it is. Okay. Okay, so you can see. Sorry, let me just copy this out of this tiny window. It's actually gonna be difficult without a mouse. No. Select end position. I've never tried that. Oh, nice. I didn't know I could do that. Let's get all the way down. Okay, so that's the raw data. Let me also get the data. Oh shit. Bear with me here. Yeah, it's a really cool tool called mprox, but it has its quirks. It lets you, yeah, I mean, you see all these processes on the left. Really convenient when you have lots of those, but okay. Let's format this thing. Let's pretend like it's JSON. Format. All right. Ooh, what do we got here? Didn't format obviously the raw data, but you can kind of see that it's binary. It might even have slash delimiter or something like that. These are just zeros, I believe. And then, yeah, so this I realized it was giving me, yeah, it's basically one element in the array for every buffer. So that if I make this a 1, let's do 10, tiny little buffer. And this actually, the sample rate might have something to do with this. Let's play around with this a little bit. So bits per sample. Let's try that. Just so we don't have to parse through so much logs. Uh-oh, invalid sample rate. That makes sense. Gotta be a power of 2 probably. Is it just too low maybe? Let's give this a multiple. Just trying to kind of make so it's easier to analyze. Okay. Still, okay, a little less data, but yeah. So I think what we're seeing here is like just a raw waveform. I don't even know like where to begin, like if it's some kind of baseline or like how I can even go from this to like, okay, there's a frequency modulated wave in here that I'm looking for. So yeah, like I said, didn't have the full demo ready, but I got as far as this, and I was like, okay, well, how do we even parse this stuff? There's obviously libraries for this, and so I think what I'll maybe do for the hackathon is just figure out how to get this quiet.js React Native library working, because somebody did plug into it. It just didn't really, I couldn't get the receiver to work. It was supposed to be, this little listener is supposed to be giving me the message in the profile that I expect it to be, so that if I play it from the same library over here, it pops up over there. So yeah, I don't think we'll debug this together, but yeah, I'll leave it there. Maybe, let's see, we got on time. We got like 15 minutes. What I could do with the remaining time is go into the structure of some of the cashew stuff. Just thought that was interesting. But yeah, if there's no other questions or other topics, yeah, go ahead.
Do you think, what's your opinion on like the UX feature of like sound-based?
Oh, I think it's terrible. But it's fun. I don't know. It's like kind of, proof of concept type of thing. But honestly, what's more interesting, more practical is, what is it, Bluetooth or NFC? Even like a wire, like how can you just need to send data between two phones. So is Bluetooth secure enough for that? Is it, customizable enough for that? Maybe I have to look into it. But yeah, I don't think audio is the way to go, to be honest. Yeah.
You can have ecash tokens on the tape.
Yeah, actually, well, yeah, I mean, there's creative ideas. If you're talking about user experience, efficiency, just trying to get from A to B, probably not. But yeah, I mean, I think there could be cool, just like, okay, you're broadcasting waves, and you can be spraying money out during a concert, and like, you just got to be listening into frequency. It's like, just kind of scavenger hunt ideas, I guess, like that. Yeah. Yeah. So it's fun more than anything, but user experience wise, I don't think this is the direction. Yeah, Morse. Okay, so yeah, last piece here that I thought was interesting. Or no. Yeah. Oh yeah, if anyone have been scanning this, that's mainnet ecash, by the way, if anyone noticed. Yeah. I'll leave this up for a bit if anyone wants to claim that. But hurry up. Maybe I messed up then. Oh, right, you don't have the, I think it was Bitcoin principles, so. All right, here, okay, yes, this is what I found. All right. Oh, that's not it. This, all right, here we go. V1 keys. So Cashew has a nice little spec here. Not for the keys. Over here. Okay, so last thing here, guys, real quick. So Cashew has an API for the keys, which are basically the denominations here. Key material to be composed of. You do that from your own seed first, but then you need a signature from the federation. And so you use these keys to combine it with your key material before you send it to the federation, so that you can unblind it later. And so if you look at any mint, for example, this one, at least a Cashew mint, there's a nice little API for this, v1/keys. This will tell you everything that you need in all the denominations, right, all the way up to however much it supports. And so yeah, your client needs to use this key in order to generate the ecash. So yeah, I think I'll leave it there, guys. Thanks for watching, and here at the definitely check out the source code, the repo we have. Check out the Fedman Web SDK, and we are hiring. There's some open positions. Let me blow that up actually here. There's 2 engineering roles we're hiring for. If you want to come help us out, build the kind of best user experience for ecash that we can possibly make. Yeah, we're hiring. So thanks for watching, and have a great rest of the conference.
Test, test.
Yeah, it works.
All right. Hello. Hello. Testing.
Hey guys, we can start.
Okay, we're going to get started now. So thank you for coming to our talk. We're going to talk about the Fedimint Lightning Gateway and the progression of the Lightning architecture over the last few years. So let's get started. So just a quick introduction. This will be a talk between myself and Joshua. My name's Justin. I go by Mr. Cool Guy on Discord. My background's in databases and cloud computing. I've been working on Fedimint since about August of 22. I've been supported by Spiral and OpenSats, so very grateful for them to be able to work on this full time. And I'm the organizer of the Minneapolis BitDevs, which is a lot of fun to do.
Yeah, my name is Yosha. GitHub handle is Joshi-san. By training, I'm a mathematician, and I joined the Fedimint project April last year, and yeah, I'm supported by Spiral, so shout out to them.
And then also, massive shout out to all the other contributors. There's been a lot of people that have worked on the Lightning Gateway, and it wouldn't be possible without everyone. So, okay, let's dive into what we're going to talk about. This will be primarily just an engineering talk about how the Lightning Gateway has evolved over the last 2 years and how Lightning works inside Fedimint. So we'll give a little bit of background and motivation for why this thing, a gateway, even exists. Talk about the architecture and how it's changed over the last 2 years. Then we'll get into specifics on the Lightning protocol, the smart contracts that Fedimint uses to send Lightning payments. So we have what we call LNV1, or our first iteration of the protocol. That's what's in production right now. And then we also have a new protocol that's going to roll out with our next release called LNV2, and Joshua will go into the details on that. And then we'll talk about some of the newer stuff that we're releasing with LDK and other things that we want to work on going forward. Okay, so a little bit of background and motivation, like why do we even have a gateway? So on the right here, you can maybe see a typical maybe Fedimint setup. You have a federation, a lot of clients that might be phones or the command line, and then we'd like some connection to the Lightning Network to go back to the broader Bitcoin ecosystem. So why is this even necessary? Well, as we've said already, Fedimint is federated, and one option would be, why can't we just build like Lightning into the federation, like a federated Lightning node? And I think this is really appealing. I think a lot of people have thought about trying to do that, but it turns out it's actually very difficult to build, not only for all the complexities of Lightning, but Fedimint is a consensus system, and we've found over the last, especially since being in production, that updating Fedimints are difficult, and with the fast-moving pace of Lightning, it'd be pretty difficult to build a federated Lightning node. So what's the other option? Well, the other option is to make a smart contracting protocol between a separate entity that allows for sort of a trust minimized interaction to provide this Lightning functionality. So the fundamental trust model for building this is that the gateways must trust the federation, but the federation does not need to trust the gateway. So gateways are simply liquidity providers that for either payments or make outgoing payments. And so that's kind of where we'll get into it, but that's where our process called, it's kind of in between the federation and okay, so what is a gateway? This image is taken directly just from the Fedimint docs. A gateway is essentially just a collection of clients. Collection meaning it can interact with more than one federation. And it interacts with the user client, being the end phone, the federation, and the Lightning node. It holds ecash to provide incoming liquidity, and this is where the trust assumption comes in. The gateways must trust the federation enough to hold their ecash. And it executes Lightning payments on behalf of end Fedimint users or Fedimint clients. So today we have 2 supported nodes. We support Core Lightning and LND. And with our upcoming release, we'll support LDK, which is an LDK node integration. Okay, so diving into the architecture. So at the very beginning, we to provide Lightning functionality, there was a core Lightning extension only. So it kind of looks something like this. There was a Lightning node. Core Lightning has a multi-daemon architecture, so the extension runs as a separate process. And clients then interact with the extension directly. And the extension actually has the logic to that we'll get into in the next few slides on how to interact with the smart contracts in the federation. It turned out, this worked, but there's some obvious downsides. There's lots of logic in the gateway, which in the extension, which made it somewhat difficult to debug. Core Lightning controls the life cycle of the extension process. So there's other things that you'd like to do with a gateway, such as maybe spend the ecash that it's holding. And with this architecture, you wouldn't be able to take your Lightning node down and do that at the same time. And then also at some point we wanted to add LND support. LND has a large market share of the Lightning nodes, and we'd love for more people to run gateway. Adding LND was fairly important. So we needed to change something. So we ended up making a new process, like a gateway D, and a lot of the logic that was in the extension before moved over to this new process. And the extension really only interacted with the Lightning node. So as part of this work, we abstracted away how we interact with our Lightning nodes, which is probably a fairly common problem with other protocols. And we have sort of a Rust trait that allows us to interact with either Core Lightning or, in this case, LND. And this architecture is totally valid. With the federation, you can have multiple gateways. They could be running separate Lightning nodes, and things should still work. Okay, so now we'll get into the actual smart contracts and how what we call LNV1. This is what's currently in production for how Lightning works. So there were kind of 4 separate use cases that we wanted to cover. There's the outgoing payment case where, say, an end user client, maybe using the Fedi app, wants to send a payment over the Lightning network. They then talk to it would maybe go from the client, to the federation through the gateway and out. We'd also want to support incoming payments on the Lightning network, so you can receive from your favorite Lightning wallet. But maybe more subtle, we'd also want to support like intra-federation payments. So maybe you have 2 clients that don't even know they're in the same federation. One shows them an invoice, one pays it, and you'd like sort of that to actually be an ecash transfer. And then also we'd like to support inter-federation payments. So a gateway that might be connected to multiple federations that also does not need to go over the Lightning network. That can be, because the gateway in this case would be trusting both Federation 1 and Federation 2, it can sort of just do the swap and not touch the Lightning network at all. Okay, so how do we do this? So we essentially have a set of smart contracts. We can go through the outgoing payment case. This is what the contract looks like. It has a hash, it has a key, it has a time lock, then to an HTLC. The hash is essentially locks the contract. The gateway key is the key that is allowed to claim the locked ecash. And the time lock is the time lock portion. If the gateway has not claimed it by then, the user can then withdraw their funds. User key is it's used for claiming the money back on a refund case. The cancel flag is used sort of as a short circuit. So it's not a great user experience if the payment fails for the user to have to wait till the timeout to reclaim their money. So what can happen in LNV1 is that the gateway can flip this cancel flag and withdraw their money immediately. So what that looks like is the client, the end user, would then federation contract federation,
the user then directly talks to the gateway and says, hey, gateway, if you can pay this Lightning, you can that's locked in this contract. So the gateway then pays the invoice, gets the pre-image back, and it uses that to claim the contract that's in the federation, and it gets paid. It gets paid its ecash. Okay, incoming. How does incoming work? So in LNV1, we have sort of two constructs. We have what's called an offer, or incoming contract offer, and the actual incoming contract. So the way to think about this is the offer is sort of the amount that, as the comment says, the amount that the user is willing to sell the pre-image. So the user essentially puts up the pre-image with an amount for sale, and crucially, the pre-image is encrypted to the federation's public key. So it can't just be stolen without ecash being paid to the user. So what happens is the user creates this offer, and that gets put in the contract. And then it generates an invoice, and it sends that off to whoever wants to pay it. At this point, the Lightning node just waits and waits for the payment, and how to do it of a HGLC interceptor. So the Lightning node actually intercepts the HGLC that corresponds to that hash, and the gateway then says, is there an offer for sale for which I can buy the pre-image for? In this case, there is, and the gateway then is responsible for funding the incoming contract, and the process of funding that incoming contract then tells the federation to decrypt the pre-image, which is returned to the gateway, and the gateway can then, and then the user can then claim the ecash that was locked in the incoming contract. So this is where the gateway needs to have the ecash, because the gateway is the one that funds this incoming contract. Okay, intra-federation. So how do we do like short circuit Lightning payments when there's two clients that are in the same federation? Well, we use the same constructs. So the receiving client still creates the incoming offer that gets put in the federation, and the sending client is then sent the invoice, and they try to pay it. So because we know that they're in the same federation, when we can figure that out, we actually do a somewhat clever trick. We take the federation ID and we put it in the route hints of the invoice. So we're kind of abusing that field a little bit, and assume that the Fedimint client on the sender side is smart enough to be able to look inside the route hint, reinterpret it, and say, is that the same as the one that I'm a part of? And if it is, instead of creating the outgoing contract and contacting the gateway, it can just directly fund the incoming contract itself. And once it does that, the receiver is able to claim that and get its ecash. Okay, and then how do we support inter-federation? So it uses the same building blocks. In this case, we actually use all three. So just on the left here, we have the incoming contract and the outgoing contract. In this case, the receiver would first create the offer in Federation B, create an invoice over to the client. The sending client is only connected to Federation A, so they then create the outgoing contract and then tell the gateway, hey, can you pay this contract? And the flow here for either of these is the same. They don't even know, like they think they're just paying a normal Lightning invoice. The trick here is the gateway is now able to determine, oh, I'm actually connected to Federations. They can go look up, is there a image for sale in Federation B that I'm able to satisfy this outgoing contract with? In this case, there is, and the gateway can then fund the incoming contract, in which case the receiver can claim their ecash. And as part of doing that, the pre-image is revealed, and the gateway can then reveal that to A and take its own ecash. So the gateway doesn't lose any money there. It actually might gain some money via fees. Okay, so that's sort of how the protocol works. We've had that working for a long time. And one thing we realized while we were building this is Gateway D must, and the user client in general, must be robust to crash and failures. All the interactions that I described there, they can fail at any time, right? So this is a code snippet of our code from a while ago. And it's a pretty good example of why you need this robustness. So on the top here, this code snippet is when the gateway is trying to buy the pre-image from the federation and then reveal it to either the Lightning Network or another federation to claim its money. And if you look closely at this, you can see if the gateway crashes right here, so it buys the pre-image from the federation, but it crashes before it actually claims the contract, then it's never going to get its money back. It funded a contract not to, but it's a sort of footing the bill. So the lesson is that like the protocol on the client side and on the gateway side must be able to resume these incomplete operations. If you've done one thing and you crash, it needs to be able to be smart enough to reboot and resume the operation. So the solution, and this is not just throughout the entire Fedimint client, was to structure all these operations as state machines. These state machines have idempotent triggers and atomic transitions. So the triggers essentially all execute in parallel. Return is then the transition function is executed need to be atomic. So as long as we can structure all these operations inside these state machines, the client is essentially guaranteed not to lose money. So I won't go into all the details on all of our. We'll talk more about that in the protocol. But here's an example of you can kind of see states and operations that it does to get from like paying an invoice to actually getting the pre-image back. We obviously covered the success cases in the last 4 slides, but we also have to handle how you do refunds. So say if the Lightning payment fails, say there's no route or something, the cash in the federation needs to be refunded back to the user client. Yeah.
So you say like it can't crash or else like it won't complete. Will the data have to be persisted, or can it be like when it's resumed, can you sort of like recreate the data along the way, like, or do you need to write the data to a disk and then you can crash it?
Yeah. What happens? The state machine during the function, it has like a so anything that you need to persist during it has to happen to disk. Yeah. Okay. So as I mentioned earlier, this was our V1 protocol. This is what's in production right now. But if you squint hard enough, there are a number of issues with the protocol. So we can go over some of these right now. So the first one is contract mutability. Both the outgoing contract and the incoming contract, that they have data in the federation that either the client or the gateway can change. It's not a fundamental problem, but it makes the hard to reason about, and then I can then reclaim its money, but you sort of have to be able to look at the state of that. Another issue that Joshua will get more into is the federation is actually the one that decrypts the pre-image in V1, which is not necessary. The gateway can do that. Also wanted to change with our new protocol. In V1, the incoming contract did not commit to the amount. which causes some issues regarding like if you want amount so that the gateway can't play any games as far as invoice creation also required a round of consensus. So what I mean by that is how invoice creation worked in V1 was that the user client would create before the image could be returned or the invoice could be generated to give to the sender. That contract had to be confirmed by the federation. So it has to go through a whole round of consensus, which user experience-wise, if for some reason running slow, is a bit of a UX hurdle. We also, in V1, we used HTLC interception to detect these incoming payments, which made things a little difficult. Essentially, what we did is in the invoice, the receiver's pub key was fake, and it was a sort of a fake last hop. So in order to allow other Lightning clients to be able to find the gateway, we needed to put the route hint the invoices that, hey, you can actually invoice, you just have to know how to route to this node. Because obviously a fake pub key in the receiver is the sender node will not know how to find them in the Lightning graph. And this is somewhat related. In V1, the invoices were created by the clients, and that's why we had to do this fake pub key. Whereas, as we'll get into in V2, we changed that. Yeah, so I'll hand it off to Joshua to talk about V2.
Yeah. Okay, let's start with the outgoing contract. Not much in Fediman receiving, and yeah, the only thing that we changed here is the outgoing contract is not mutable anymore. Before the gateway there are 3 different ways an outgoing contract can play out. It can be claimed by the gateway with the pre-image. It can be unilaterally refunded after it has timed out by the user. And it can be collaboratively canceled with the gateway. So then the user can do with the ecash in there whatever he wants. And it used to be the case that the gateway would do a transaction with the federation to set this outgoing contract to cancel, and then the user could claim it unilaterally. Since we don't want our contracts to be mutable anymore, it's going to be even more similar to an HTLC now, since the gateway is going to give the user a signature that confirms its cancellation. So it has a static public key, which is the claim public key that he would otherwise use to claim it, but he can sign the hash of the contract, and means it forfeits the contract to the user. And the user can then use this so-called forfeit signature as a witness. So the structure with LNV2 of the contracts is you have the immutable outgoing and incoming contracts, and then they have different branches to be consumed as inputs in a transaction where you then provide a different witness variant and associated witness data. And witness data might be the forfeit signature, it might be a pre-image. Yeah, or in the case of like the unilateral refund due to timeout, there's nothing in the witness besides this variant specifying I want to use a timeout here. The incoming contract here changes a lot. There was kind of the whole idea behind doing LNV2. That's what I started out with, because originally, as Justin had explained, when the client encrypted the pre-image, it could not commit to any public data while doing so. And in order to assure that a certain amount, namely the amount in the invoice that it actually gives to the person wanting to pay him, is paid for this pre-image, it needed to do a transaction with the federation which doesn't have any financial value, which is weird for many reasons. It doesn't have any financial value, and the only register with the federation for the, and this broke between the client and the federation, and it's just very ugly as well. I think it's like non-financial transactions there. It only has an output, doesn't have inputs. Output is 0 value. It's weird. So what we've done instead is here, well, we developed a threshold encryption scheme that allows to encrypt the pre-image, and also while you encrypt it, you commit to like a SHA-256 hash of public associated data. So when you want to decrypt the pre-image, you always have to supply this associated public data with it, and then the federation can check the contents before it starts the decryption. And there are many multiple of conditions put on that that are committed there to. Most importantly, the amount for which the federation can decrypt this pre-image. So the advantage of that is now that when you want to generate an invoice, you don't have to do a transaction with the federation anymore. You can just generate this incoming contract, and then you send this to the gateway. As a he wants to take a cut there. Yeah, so therefore, if you set up the receive, there's no interaction with the federation. We don't create a Fediman transaction to do it. That makes this much simpler. Also on the client side, there's no state machine that needs to handle this. This is like a regular, it's just an HTTP call to the gateway, some cryptography in there. Yeah, and off you go.
And the main trade-off here is that because now the interactions with the gateway and not the federation, the Lightning payments actually require a gateway now. So that the payment is no longer supported in V2.
So yeah, before there was an edge case where if the gateway was offline, you can generate an invoice, and if it happens to be an intra-federation payment, which you don't know when you generate the invoice, then this is still successful while the gateway is offline the entire time. However, even with LNV1, since you don't know if it's going to be intra-federation or not, do you really want to create an invoice for a gateway that is offline right now? That is a really bad user experience because you think this payment is successful, can be successful, you give out the invoice, and then paying them not going to fail. It's just going to fail. So what we would rather have in that case anyways is that if you would try to generate the invoice, your app says, sorry, gateway's offline. So we changed this for LNV2. We want this online checks anyways. So LNV2 is not going to initiate payments anymore if the gateway is not on, like the first thing that is checked. And we use this online check to also fetch the invoice now from the gateway. It's not generated before we put the gateway in the route hint, and then we have this fake last hop, which is like kind of the user's fake lightning node. Well, first of all, it's a bit weird. It's unusual use of lightning, and we've seen probing issues with that, failing, I think, Strike to pay some of our gateways. So lesson here is use lightning in the most canonical way possible. So we switch that. We don't mess around with the route hints themselves anymore at all. We just ask the gateway for an invoice, which is an invoice. It's a established working concept, and this is given by the user. Yeah, so this like significantly simplifies the whole receive flow as well, and has the additional benefit of getting the cryptography for this in-house instead of further relying on like an outside, somewhat outdated package. Yeah. Okay. What do you have here?
Sorry, this was the outgoing flow.
Yeah, this is the outgoing flow. So maybe we can go into the state machines a bit here. First state is called funding. So we are focused on the user client state machine here. First state is called funding, which is a transaction, the outgoing contract as an output, and it has ecash as an input. We wait for this to be confirmed. This can be rejected. That would be due to a programming failure only, otherwise the transaction cannot be rejected.
Or if the federation's offline.
I think if the federation is offline, actually that should hang here until the federation comes online. Yeah. Yes.
Yeah.
We should.
Oh, sure.
Yeah. And the thing is, what the worst case scenario is, actually this transaction is successful because it is out there and it is valid. So it might be like just stuck in one of the guardians, we stop retrying, and then this transaction is still confirmed with our money, the ecash is gone, and that we have an outgoing contract created that we are not managing anymore. So yeah, that money would just be lost then until we recover, of course. Then this outgoing contract would be recovered. And now funding state is yeah. So we do an HTTP call, like we create the outgoing contract, we do an HTTP call to the gateway. Here's the outgoing contract. Here's the invoice, the amounts, expiration, etc. of the contract in the invoice. They match up. They comply with parameter gateway to initiate payment. And then in time, the gateway will answer this HTTP call with the pre-image for the invoice. In client shows the gateway as shows the payment as completed to the user. That is all the proof he needs. He has a pre-image. It was released by the receiver. Yeah. Otherwise, there are two options how to refund. Gateway. The next most likely gateway could not make the payment. Forfeits go through the HTTP call, and the client and cancel the outgoing contract. In the worst case, gateway goes offline, contract times out, probably within like 500 blocks or so, and so like 3 days, and then the user will refund the outgoing contract unilaterally. Yeah, state machine on the gateway side is not that important. Okay, yeah, receive, much simpler. So also we just focus on the user client here. When we have created the invoice and given it out, we also have created the corresponding incoming contract. And now we're just waiting for this incoming contract to be like appear as an output. So create a state machine that takes the contract of that contract, which is just its SHA-256 hash, and it does a single WebSocket connection to the federation and say, I want to wait, like notify me when the contract with this contract ID appears, and then it just waits, you know. And at some point, the gateway might fund this contract. It's confirmed this web subscription is going to return success. And the gateway will, like, in the user's client can now show the payment as immediately completed. Know that the incoming contract, and it can later even need to wait for showing this, like issuing the as completed to the user. Just by the contract ID, which is the hash, we know that exactly the contract that we have generated has now been confirmed, and therefore we know we have a valid witness, as long as we don't have any programming out there, and we'll be able to claim it successfully and issue the ecash. It never shows assure that if the state machine expires and stops looking for the incoming contract can actually not be confirmed anymore. When we encrypt the pre-image, we as part of a public data that we are committing to, we put a Unix time in there, and we say, okay, this is the latest time that you can decrypt this pre-image. Any later, don't do it, and if the gateway still tries, it will be declined. So we can safely stop listening to this, or stop listening for the incoming contract, and are not risking that actually whoever wants to pay us takes the payment, stop in the ether somewhere. Yes, so far for the state machine. What's the next
Yeah, I'd
one?
like to point out too that you know, the receive and the complete state machine are separate, and in LNV1 it allows us to sort of reuse them, say for the inter federation or incoming payment over Lightning case. So okay, so that was LNV2.
Let me add one thing. So, as I said, generates the which has aforementioned benefits, but furthermore, actually kind of like registers, like implicitly registers the payment with the gateway. LNV1 did not do this. The gateway did not set up a payment coming for him, and that is fine for CLN and LND, where we can use HTLC interception for like unregistered incoming payments. However, LDK internally does not support it, and they need a payment to be set up with like a HODL invoice before. So yeah, therefore, what we want to do anyways, that the gateway generates the invoice, just makes this much simpler because it will implicitly register the payment while you're doing so with the Lightning source, thereby enabling LDK as a backend.
Yeah, that's a great point. I mean, part of the motivation for moving to LNV2 was to have an LDK gateway. And there's more benefits to LDK than just that too. As the slides say, you know, right now running a gateway kind of requires managing separate daemons. You have to manage gateway D and then also either LND or Core Lightning. And it'd be nice if you didn't have to do that. So essentially the way it'll work is, as with most LDK integrations, we use LDK node, and it'll be directly actually inside gateway D itself. So gateway D will be a Lightning node, and you'll be able to manage your Lightning node from just by using gateway D. So from the other work that we've done with LNV2, and then also just earlier, like abstracting away how we interact with the Lightning node, this integration was actually fairly straightforward. But we did need to build a decent amount of management tools because it's sort of an increase in scope of the gateway. The gateway is now also a Lightning node, so we needed all the typical, you know, open channels, closed channels, and shout out to Tommy for spearheading most of that work. We also want to implement the LSP spec, so like the end vision for maybe a gateway operator would be not actually needing to manage liquidity at all, and you could do some interesting things with ecash there as far as how to balance. Okay, so shift topic a little, sort of topic of running gateways. We're hoping that with the new release in 0.5 that it'll be a gateway, but obviously today, especially with the V1 protocol still was in production. There's still, like, running a gateway kind of comes with all the challenges of Lightning and ecash, which a lot of people are probably not familiar with. But one takeaway is that like federations don't necessarily need to run their own gateway, as long as you sort of have this trust relationship. Run the gateway. So that's what we've done. We're running a production gateway right now. We've connected to a few federations, and so if you're a federation operator and want a gateway to be connected to you, let us know. There's still obviously a bit of manual interaction here because of the trust relationship, but we are running one of these, and we'll connect to you if you reach out. Also, inbound liquidity is also very much welcome to this Lightning node. We're kind of running this on a best effort basis. You know, it's a community volunteer-driven effort. So failing, we'll as we can. Okay, just wrapping up a little bit. What's next? What can we do to further the Lightning Gateway? Well, right now we're focused on LNV2 deployment, getting new federations to upgrade, getting gateways to upgrade, and then getting client adoption. Would love to see more wallets integrate LNV2 because that's what will be in production going forward. But there's also a lot of other cool stuff we can do. So such as with LDK, we're looking into like backing up your channels using VSS. We'd like to enable MPP. Currently, Fediment coming MPP payments. I mentioned the liquidity management via the LSP spec, and there's we'd love to integrate. Receive. Tackle that first and see when we can get to receive. Okay, that's all.
One more thing I forgot to mention specifically on LDK. I want to explicit, like we built this on LDK node, directly on LDK. And I would like to explicitly credit the LDK node folks as they made the API changes necessary to enable this. The thing is with it could almost run on a custodial backend, but not quite. For sending it could, but for receiving, we need a little bit more hooks. So we like almost need like just a very simple full node interface, but not quite. And LDK Node in their O2 version, they implemented this this like full node interface, which worked for send but not for receive. And then they like introduced more hooks into their API and pretty much built like a perfect API for us. Exactly what we need and nothing we don't need. So yeah, this was extremely helpful and made this LDK gateway, which is probably becoming our preferred gateway, to be honest, possible with only a few calls. Yeah, so it was great.
What node are you running?
The one I mentioned here.
Yeah, what Lightning node is on?
This is this node is LND. The LDK release will be available in 0.5, which will hopefully be cut soon after this conference.
Yeah, and yeah. So as you said, we are running one ourselves in an effort to dogfood our own software and verify that we actually get like consistently low latent like payment latencies and high reliability in practice. And we're going to do the same thing. So this one is on LND. Because the LDK gateway requires Lightning V2. But we will spin up the Fediment gateway V2, have 2 deployments, and this obviously run LDK, so we can like verify all of this in practice, track payment latencies, etc., etc. That is something that was not explicitly mentioned in the thing that we can do next, because it's obviously of a feature, but a lot of the work we do is just reliability, latency, reliable, low latency. Flashy features, they look good on a slide, they're easy to understand, but cutting down on your tail latencies is also, in our opinion, very important for the user experience to establish like trust in the system for non-technical users. Like everyone gets angry if their payment takes 20 seconds every now and then. And yeah, we take a bit of with LNV2 with the gateways, we take a bit of a different philosophical approach there with the registration. While before gateways could just come and go and like register themselves for service, the idea there being, well, and gateways untrusted, so everybody can do it, like a Lightning routing node. With guardians have to. It's a simple process. You just take in UI, and then your clients will start routing over them. So the Guardians, like one of their jobs is to like curate a small set of highly reliable gateways because it affects their user experience. You know, we start gateway.
It's worth mentioning that doesn't change the trust model around a gateway. It's mainly about user.
No. What you trust the gateway for is making your payments fast. And if your payments take 20 seconds on a gateway, that's just not a great user experience. And yeah, we want to avoid that, and Guardians should be able to avoid that. Yeah.
To create or get people to set up new federations?
Yeah, and in my personal opinion, we should not make it, like, also focus on making it easier to run a gateway. Yeah. But if someone wants to federate, the answer should not be really easy. The answer, we start off with that, and we bootstrap federations like this, and then in the long run, if they say we have someone who can like provide a gateway as this level of quality that we do, just for our organization, because our scale is that big enough, then they can transition to their own gateway and they can maintain ours as backup. So the clients, they will automatically start to distribute payments, and if one of the gateways goes offline, they will immediately switch to the other one. That is having multiple high quality gateways is then great, because like why have more than one? Is quality, but that if one of them goes offline, maybe just due to like migrating it or maintenance, something like that, the users will experience zero downtime.
Yeah, and I think that's just the fundamental trade-off that we made here. Like, why build a gateway that's high availability when that's like the easiest way of making it highly available.
Yep. If it is online, though, it has to be fast. That is kind of like, there's no around that. Very deeply, yeah. So,
and I guess if you're sending from one federation to another, then you're not incurring the potential to generate revenues from that as higher.
Sorry, come again?
Sending between one federation and another, you're effectively cutting out the Lightning Network and still it's chucked.
Exactly. So it's optimized. LNB2 is optimized also for this one situation where you have like where you have like maybe a handful of federations that are locally closed, so they have a unique amount of traffic between them. In that case, it would make sense that they all they share the same handful of gateways, which also just from the trust situation makes sense. And then the payments would never go over Lightning, and you would save on the Lightning fees and you would save on latency. So you would see extremely fast payments with like second or like at most 2 seconds if lightning payments between those federations are made. Yeah.
How do you test all that stuff?
Yeah, we got a pretty extensive testing framework. So as I said, we have like 3 different backends. So let's just go through it. So for like the Lightning V2, first of all, we have like full test coverage for the consensus. Every branch that is taken, since we split it up with like the different witness branches, we can like in our test suite, every single consensus branch and every single stake machine branch on the client is taken. It's executed once, and then furthermore in the testing, so all the failure cases there are also tested, all the misbehavior from the gateway that the client reacts correctly is tested. And then we got integration tests where we have 2 federations, 2 federations for 1 LDK. And then we do, we get testing matrices with the gateway, so like and then we got the option of like, then we get another multiplier where we have like same federation, 9 of gateway that a client can pay with, and then 2 federations connected to the same 3 gateways, also 9 differential of payments that we route. So every time we make a change, we route 18 lightning payments, and I mean there's even more redundant testing, you got overlap, etc. It's a pretty big test suite.
Yeah,
in addition to all the
and the integration tests actually spin up all these daemons. We have a crate called DeviMint that sort of handles a lot of that. So
And you can also
do yet. As you said, that's something we're going to be investigating in the coming months.
I mean, doing the latency test and that kind of test suite is difficult because all of this runs on the same machine, so latency comes there, or can come there like primarily from like being clocked. Yeah, I think just to put this into context, I think we spend a lot of money on CI. Yeah. So, and for me, like for my laptop, none of this runs locally. So you need a beefy machine to even be able to run this locally, or we're actually more transitioning to doing like remote compilation and remote testing. So you do the changes locally, and your editor runs locally, and then you sync to a beefy server, maybe on the order of like 32 cores,
the unit
128 gigs,
unit test
run there.
Yeah,
You compile it rather than on the remote machine. Yeah, all the tests, we are not running box here. It's like actual NFTs, core Lightning nodes, LDK nodes that are running on actual Bitcoin nodes, where we then, for example, manipulate the block time, etc. We got a whole testing framework for that. So, for example, the expiration, so this is it's right there actually. So, the expiration of block times. So, we set up the receive, and then we start advancing the block time, the block height for our like fake Bitcoin network, but it's real nodes. And then the federation, their guardian, the federation's guardian, they fetch the higher block times for from their guardian from their Bitcoin RPC interfaces. And then the consensus block time will advance, and then this will trigger the client whose federation will tell them this contract is actually, and it will trigger the same machine, and that's just like one test of like 2,000. Yeah. So yeah, that's kind of our standard for everything we ship. It's like that level of test coverage. Yeah.
Maybe a more dumb question. Literally, what is the state machine that you're changing a value of and then having logic for?
Yes, the state machine is literally just an enum.
There's a bit more to it. There's like an executor that sort of executes these trigger functions in parallel. But yeah, that's the basic idea.
In the module, it's very neat because in the module you just see an enum, and then you define the triggers and the triggers as like async futures, and the transition functions also as async futures. And for example, the transition functions, they get like a prefixed, so like a sandbox database transaction where you get like your separate namespace just for the modules. It's all isolated. You get all of that set up. You just really focus on your business logic and nothing else. And then the client magic comes in, which takes like typed state machines. For example, you also get like a context passed in where you can like execute calls on the client itself. So and then the client takes those state machines for the modules, which are typed, and it then does type erasure on this, and then it has this like stack of type erased state machines from different modules with like type erased context, etc. And then it will execute all those triggers in parallel, and whatever state machine, whatever triggers returns first, it will enable that transition, and then it will create the database transaction, it will create the context to pass in the triggers, and then on the transition it will create the database transaction to pass in, and it will like pass in the prior state as well, and it will do all the casting in between, so it like downcast to the corresponding type. So that is, you don't have to do this if you write a module. Like it is very simple in the code, like defining a state machine, like just enums and HTTP calls and and stuff like that.
Yeah, lighting is just one example of a module you can build on Impediment. So the Mint module works the same way. All the clients do the state machine logic. So.
Can you do like static analysis to determine like if you're missing like state machine paths or like possible steps?
Well, static analysis on this would be a bit difficult, but we have for Lightning V2 we have done this by hand. So the tests are kind of built in a way that you like shut down certain parts, or we have mocked out the gateway, for example. So we can, the mock gateway can be, depending on what type of hash the client requests, this mock gateway will have malicious behavior. It will only do like, it will take certain branches, which are otherwise, it would usually take the fastest. It will either take the first or the second. So in the test, the gateway took that branch and will exhibit that behavior. And so that this state, when you achieve this final state, you would have had to take a certain path just to get there. So yeah, this is just done by hand. Yeah.
Gotcha. Cool. Thank you.
We got a few more minutes, otherwise we're almost done. Any other questions? All right.
Okay. I
We'll
guess.
wrap it up there. Thank you.
Yeah, I think now we take a break, eat, and then back later.